Hey, and welcome to Today to Make It. I'm Mike. So we are going to take a deep look at this printer, the Ender 3 version 3. It's a metal frame printer, and we're going to be taking it apart. Hopefully, we're going to be able to get it back together. We're going to make some test prints on it as well to see how it performs, see if we can find out all about the good stuff and if there is any room for improvement as well. So, stick around. Thank you to each of you who have subscribed to help make this channel more sustainable. We are still quite a ways from the goal, but every subscription helps to get there. It's incredible to see how fast this channel is growing now, and it's only making me more motivated to get better content for you. This is one of the newest CoreXY printers, and it's a really slick looking printer, at least I think so. I've moved mainly into more CoreXY format printers, but I'm still willing to see what these printers can do, so let's take a look. I'm not going to assemble this yet. I want to have a closer look at everything, maybe even take some things apart as well. At first glance, I noticed this printer is different from the other bed slingers I've seen. This has a cast aluminum or cast aluminum alloy base. And if we have a look at the gantry as well, it is also cast, but the gantry is one piece, and that's pretty unusual. Normally you'd see a cross member here joining the two posts together. This printer is a CoreXY style printer, and that means that it has these two motors that are activating both the Z and the X direction as well. The Y direction remains still driven by a single motor. This printer has a build size of 220 by 220 by 250, and the first thing that I looked for was the size of these rods and the position of the rods as well. They're spaced quite far apart compared to the other bed slingers that I've been testing, and they're 10 millimeters in diameter, and I took a measurement pretty close to 10 millimeters right on. And if I test for any movement, I can feel just the slightest amount of movement. Not much at all. Underneath, it's a little bit difficult to see, and we'll have a closer look at this later. The bearing blocks are attached to an aluminum bed, but the bearing blocks are 54 millimeters long, rather than on the other bed slingers being quite a bit shorter, I think around 44 millimeters. So that's also going to give it quite a bit more stability. So now we have the rods spaced further apart, and we have bearing blocks that are longer, and we have larger rods, and we have longer bearings as well. All of that adds up to a far more stable bed. I've clamped it up just so we can have a closer look from the sides. You can see this larger bearing block, and I checked, and the bearing travels from end to end, and that is 54 millimeters long. And you can get a closer look at the slightly over 3 millimeter thick stamped aluminum plate. And while we're looking underneath here, you can also see that there are 4 strain gauges. There's 2 here and 2 on the other corners. This distance is quite a bit closer, quite a bit tighter than on the other bed slingers. They've really done a good job of trying to get this as condensed as they can. And this is also insulated on the bottom of the bed. And I would assume that's because that'll keep the sensitive electronics, which are down in there, away from any heat on the bottom of the bed. I also notice a very long cable coming out of the back of the bed. So no matter where it travels, it's a pretty large loop, so there shouldn't be any issue with any straining on that cable. It's also very flexible. It feels like it's pretty high quality, not plasticky. We can also see that we have Gates belts. So these are the limit switches for the X and for the Z travel. I'm going to see if I can at least take the bed off. It looks to me like I can remove these 4 screws, so I'm going to try that. Interesting. There's a tiny little wire coming up through the front into some sort of sensor. A nice smooth motion. Now you can see the 4 strain gauges. And those 4 strain gauges are there because of the way that we do auto bed leveling now. There is no probe on the bottom here, so it uses pressure from the nozzle against the bed to determine the height. You can see how tight everything is here. There's not much space at all. Looks like they did a pretty good job of lightening up the aluminum frame as well. It all looks pretty professional and pretty clean, fairly well thought out. I can't say I've ever seen one of these before. There's a little bit of adhesive on there as well. This is some sort of proximity sensor. It says LJB28. So there is no limit switch for the Y travel, so maybe this is what takes the place of it. I put it back together. The only thing that I can think of that comes near to that sensor area is the front of the bearing. That's my guess. I'm not 100% sure on that. And we can see that the base has these vent holes integrated directly into it. I'd also imagine that the entire base acts as a big heatsink because of it being aluminum. And it looks like several of the boards have unused connections, and maybe that's to make them more generic or possibly for future upgrade options. And the Y-axis motor is pretty beefy. Here is that small wire that goes towards the front. This being a CoreXZ, it's very similar to a CoreXY, especially if we lay it flat like this. It's basically the same. So when we move side to side, we are sharing the load between these two motors. But when we move up on a diagonal, only one motor is being activated, more or less. You have to get just the right angle. For the most part, both motors are going to be sharing the load the majority of the time because the movements are going to be front to back and side to side. We have a filament runout sensor, and it goes up and down with the X-axis. I'm not sure why they weren't able to put the filament runout sensor inside of here. We'll open this up and have a look at what's going on inside there. There is a 10mm rod up on top, and then there's an 8mm rod down below. The 8mm rod has a bearing, and the 10mm rod has a bushing. We have springs on both sides. It looks like there are some springs in here as well, and these will pivot, creating an automatic tensioning system. I noticed that there are 1, 2, 3, 4, 5, 6 threaded holes that are not being used at the moment. And I'm curious to know whether they were from the painting process or maybe a fixturing system that they had set up in order to get everything exactly in the right position. There is a fan right on the back to pump out some cool air, because this is going to be a high-speed printer that needs an additional cooling fan. So it's like an auxiliary fan, but mounted right to the hot end assembly. That's a pretty nice fit onto there. This format of printer with a CoreXZ is not susceptible to some of the issues we'd have with the older style of printers with a lead screw for the Z travel. And that's because there is no lead screw that can wobble around as it's rotating. In this case, we have the belts for the motion that's going up and down, and we have the rods and linear bearings. So as long as these are fairly straight, which I'm sure that they are, there should be no issue with Z wobble on this printer. The assembly for this printer is really simple. The gantry bolts to the base with 8 button head machine screws, 4 from the front and 4 from the bottom. We can connect the wires for the motors, and then we can connect the wire and zip tie it to the head, which makes for a pretty secure connection. The spool holder itself is also pretty beefy and it attaches to the frame, and there's this extra kickstand which I believe is meant to provide some support and absorb and reduce vibration, because otherwise the spool would sit off to one side. I'm running the calibration process for input shaping and for auto bed leveling for the first time. So I switched from carbon fiber filament just to regular PETG. I'll just do an extrude. Let's go ahead and get our first print going. I did some pressure advance testing, and I've done flow testing as well. This is just PETG. And on my first print, there really was too much cooling. Now it's pretty cool in the shop at the moment, and this was coming away from the build plate as it was printing, and you can see the effects of that. So it stayed in contact with the build plate over here. There really isn't much surface area in contact here. And this is mostly a solid part, and it just came away from the plate. And I thought I'd try an idea that I've had for quite some time, and guess what? That idea worked pretty darn well. So let me run you through that step. So all you need is a blanket or a towel, and it needs to be pretty big. And if you have a ladybug on there, even better. So let's get one more print done this way. Okay, the print just finished. Let's take a look at what the temperature reading is. 39.3. It's quite a difference from the air temperature in the room. And how did the print turn out? That looks pretty good, actually. I do have some more dialing in, obviously, with the pressure advance, and I also could not get the seams in CoreXY Print exactly how I wanted them. There's a little bit of variation because of the way the seams are positioned. This technique is obviously not perfected. This is just the concept, but there is some potential here. Just simply putting a blanket over makes a pretty big difference. So these are all of the samples that I printed on this printer. And I also have a few over here just for comparison. Pretty well, everything was consistent. No matter which parts I was printing, I was having the same type of results. So here's one example. Now this is top-down lighting, so it is going to show off all of these defects. And just for comparison, I have a print from another printer. This is from the Bamboo X1C. Same filament, different results. Here's another example. So this is Titan Gray, PETG carbon fiber, and again, top-down lighting. You can see a little bit of inconsistency in the print. And then for comparison, I don't have the exact same color, but it is the same filament and same manufacturer. This one was printed on the X1C or possibly the Qidi Q1 Pro, I can't remember. This was a while ago. I've spent about a month testing this printer on and off, so here's a quick summary of the good points and some areas that I'd like to see improvements on as well. Most important first, does it produce prints right out of the box? Yes, it does do that. There is a bit of assembly required, so it's about 15 or 20 minutes, probably less if you take the time to read the instructions. Maybe I've been a little bit spoiled with the print quality on some of my CoreXY printers, but for me, this one falls a bit below the quality on the X1C and the Qidi Q1 Pro. The quality is very similar to what we would see on the K1 and the K1 Max printers. My guess is that the design of the extruder is the main source of the problem because it lacks the support for both sides of the extruder gears that other high-speed and high-precision extruders have. Unfortunately, I can't say that for certain until I can find a way to swap the extruders to prove that point. This is a fast printer, and like the K1, it seems to do just as well printing at high speed as it does printing slower. The frame is nice and solid. The way that the gantry connects to the base with fasteners coming from two directions works really well. Both the base and the gantry are also very rigid, which makes a very nice, sturdy frame. While it is possible to upgrade this printer, it's not going to be that easy. If you want to add something, you can use the existing tap holes that we looked at before, or you can drill and tap your own. That is one benefit of this whole frame being aluminum. There have been some comments about how the back of the gantry is open and it doesn't look very nice. Personally, it does not bother me at all because 99.9% of the time we will be looking at the front of the printer. The overall fit and finish of this printer is pretty good. It does look really professional and it is easy to grab and take along with you if you're going somewhere. I would like to see the runout sensor move to above or even inside of the extruder. Having it outside makes it harder to feed filament through. To load the filament as well, I'd want to raise the Z up because it's a little bit hard to do when it's all the way down. This printer has a pretty innovative auxiliary fan attached to the head and it seems to work extremely well. I printed this tall cylinder at 200 millimeters per second with only one inner wall and one outer wall. Of course, one outer wall is normal, and I was able to cool it. It's controlled as if it was a side-mounted auxiliary fan, and this printer can also bridge better than any printer I have tested so far. Bridging PETG carbon fiber with a 0.16 millimeter layer height over 100 millimeters without a problem is pretty good. This printer is pretty loud. It's open and it's fast, so if you're looking for a quiet printer, this needs to go into an enclosure or into a different room. It can also produce sounds like whistling noises on occasion, so if you like to be whistled at, this does a pretty good job at that. Overall, there is a lot to like about this printer. I can tell that there was a lot of care taken in the design, and just about all of the issues that I've had with previous bed slingers have been addressed. From my testing, there is only one main point left, and that is how to achieve a more consistent extrusion on this printer. I've tried to change the slicer settings, I've tried different materials, I've tried different parts, I've tried different speeds. I've tried a different slicer as well. I've used Orca slicer to see if there's anything that I can do to have control over it, and it doesn't seem that that's the case. I don't really have an answer to this question yet, and I have been searching for some time. I am using harsh lighting in my videos on purpose, and most people are not going to notice nearly as much as I have shown here in this video. That's why I wanted to compare it against some of my other printers like the X1C printer. So this is the extruder motor and extruder assembly, and this is very similar, if not the exact same as the K1C. We're going to open this up and take a look at what this looks like on the inside. These are not identical to the K1 and K1 Max though. There's a few little changes and upgrades to them. So you can tell this is spring loaded, the other ones are not spring loaded, and there's a spring right behind this extruder gear. And here's the inside of the cover, and there is a change here. I don't remember seeing this before. This looks like it intersects the filament path, so my guess is that this will be a future upgrade for a filament runout sensor built right into the extruder. I'd like to see if CoreXY can come out with an upgrade cover for their extruder with housed bearings so that we can insert a custom bolt that would provide support to both sides of the extruder gears. The upgrade would then apply to the K1, the K1C, K1 Max, and to this printer as well, since all of them use just about the same covers. For me, shooting video on a bed slinger is far easier than inside of an enclosed printer, but probably that's not going to be very important for most people, and there are some potential downsides to printing on a bed slinger. We have an increase in the mass as the print continues, and that y-axis is only driven by a single motor. And the other issue is that we have really inconsistent cooling unless you decide you want to cover your printer up, which can potentially lead to failed prints or warpage on your prints at least. I just want to say I've been completely overwhelmed with all the positive feedback over the past month. This channel seems to be picking up a lot of steam, so thank you to everyone for your incredible support. It is becoming a little bit too much for one person to respond to every single comment in detail like I like to do, but I still try and read all the comments, so if you have a question about the printer, please let me know. I'm also thinking about doing a Q&A a couple of times a month with questions from the comment section, so please let me know if you'd like that idea as well. Thanks to CoreXY for sending me this printer out to test out. I will have links below if you think this printer is right for you, and the link does help to support this channel and making more content like this. I will also have links for my top picks for enclosed printers as well, if that's more your cup of tea. And thanks to each of my patrons for helping to make these videos possible, and if you would like to help support this channel as well, there is a link down there below. Take care everybody, and we will see you on the next one.